Hello listeners and viewers. Welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration, under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned as always to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hello, students and my dear listeners. You are welcome again to yet another privilege in e-learning, and today we are going to be considering the next subtopic under sequences in mathematics, and it is geometrical progression or exponential sequence. Geometric progression or exponential sequence. Now let's start with our definition. What is geometrical progression? What do we mean by exponential sequence? A geometric progression, abbreviated as GP, is also known as exponential sequence, is a sequence in which any two consecutive terms differ by a constant multiple called the common ratio. The common ratio is denoted by letter R, while its first term is denoted by letter A, just as the linear sequence. I repeat the definition. A geometric progression, GP, also known as exponential sequence, is a sequence in which any two consecutive terms differ by a constant multiple called the common ratio. The common ratio is denoted by letter R, while its first term is denoted by letter A, just as the linear sequence. Let's cite examples of geometric progressions. The following are geometric progression with their common ratio indicated. The following are geometric progression with their common ratio indicated. Example 1. We have 3, 6, 12, 24, and so on and so forth. If you observe, the common ratio there is 2. What do we mean by common ratio? It is a rule obtaining the subsequent term. So if our common ratio is 2 in the first question, it means 3 multiplied by 2, you will get 6. 6 multiplied by 2, you will get 12. 12 multiplied by 2, you will get 24, and so on and so forth. In example 2, we have 81, 27, 9, 3. Our common ratio in this case is 1/3. Our common ratio is 1/3. So if you want to get the subsequent terms, you multiply each term by the common ratio. In example 3, we have our sequence as 20, minus 10, 5, minus 2.5, dash, 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 dash. The common ratio in this case is -1/2. It is a constant common multiple, and it is known as a common ratio. So if you want to know any subsequent term in that sequence, you multiply each by -1/2 as our common ratio. And we should take note that, student, you should take note that the common ratio is determined by R equals to T2/T1 and is equals to T3/T2. If you like, T4/T3, and so on and so forth. That is how our common ratio is being determined. Now we have the nth term of a geometric progression. The nth term of a geometric progression. The nth term of a geometric progression is given by T subscript n equals AR raised to the power n minus 1, or UN equals to AR raised to the power n minus 1. I repeat, the nth term of a geometric progression or exponential sequence is given by T subscript n equals AR raised to the power n minus 1, or U subscript n equals to AR raised to the power n minus 1, where in the formula Tn is the nth term. Tn is the nth term. Our A is the first term. Our A is the first term, just like in the linear sequence, while R is our common ratio. Our R is our common ratio. Now let's have examples so that we can be able to apply the formulas given to determine any question that may be asked. Examples in each of the following GPs. In each of the following GPs, find the A, common ratio, B, seventh term, C, nth term. Again, in each of the following geometric progression GPs, we are expected to find the A, common ratio, B, seventh term, C, the nth term of the GP. Question 1, we have 32, 16, 8, etc. and etc. While question 2, we have 3, minus 9, 27, etc. and etc. Now let's see our solutions. Solution to number 1, A power. We are expected to determine the common ratio. Our common ratio, which is R, is T2/T1. T2/T1, that is the second term divided by the first term. And the second term from the sequence given is 16, while the first term is 32. So 16 divided by 32, the result is 1/2. 16 divided by 32, the result is 1/2. That is our common ratio. We go to B part, which is we are expected to find the seventh term of the GP. We are to find the seventh term of the GP. Now you state the formula for n term, which is Tn equals AR to the power n minus 1. And our T7, therefore, because from the question given, our first term is 32, which is A. Our common ratio that we have derived is 1 over 2, and then the nth term is 7. Now, as we substitute, we have T7 equals 32 open bracket 1 over 2 close bracket raised to the power 7 minus 1. T7 equals 32 in bracket 1 over 2 raised to the power 7 minus 1. If you simplify that further, you will have T7 equals 32 times 7 minus 1, it is equals to 6. So 7 minus 1 will give you 6. So our T7 will be 32 multiplying 1 over 2 raised to the power 6. And 1 over 2 raised to the power 6 implies 1 over 2 multiplying itself in 6 times, 6 places. So if you multiply that tentatively, you will have 32 multiplied by 1 over 64. Because 1 to the power 6 is 6, 2 to the power 6 is 64. Having that, we have 32 divided by 64, because 32 times 1 is 32, and then over 64. 32 divided by 64, the result will be 1 divided by 2, 1 over 2. That is our 7th term. Now, question C, we are expected to find the nth term of the GP. We are expected to find nth term of the GP, and the formula is Tn equivalent to AR raised to the power n minus 1. Tn equals AR raised to the power n minus 1. And if you substitute your first term, which is 32, into 1 over 2 raised to the power n minus 1. Since we are looking for nth term, we will not replace n with any value, because it is the nth term we are looking for. Now, 32 is now transformed exponentially. We transform 32 exponentially. That is why we are having 2 raised to the power 5. If you transform 32 exponentially, it is 2 raised to the power 5. Now, removing the bracket, naturally bracket is multiplication. We have 2 raised to the power 5 multiplied by 2 raised to the power minus 1 in bracket n minus 1. 2 raised to the power 5 times 2 raised to the power minus n plus 1. Applying the laws of indices, when you have 2 bases multiply themselves, you pick one of the base and add the index. So in this case, we have 2 raised to the power 5 minus n plus 1, because plus minus, it will give you minus. Plus plus, you will still get plus. Now, by simplifying, 2 raised to the power 5 plus 1 is 6. So we are now having 2 raised to the power n, 6 minus n. 2 raised to the power 6 minus n. Therefore, our nth term, the general formula used in obtaining that sequence, is Tn equals 2 raised to the power 6 minus n. Tn equals 2 raised to the power 6 minus n. My fellow student, if you want to check, you can verify by substituting your values starting from first term, which is 1, second term, which is 2, and so on and so forth. So if n is 1, T1 will be 2 raised to the power 6 minus 1. And it will give me 2 raised to the power 6 minus 1 is 5. So the result will be 2 raised to the power 5. And 2 raised to the power 5 is 32. That is why the first term is 32. Question 2. Our first term is given as 3. Our common ratio minus 3. And our n is 7. So our first term, we are expected to, the first question we are expected to find the common ratio, T2 over T1 equivalent to minus 9 over 3, which is equals to minus 3. Again, R, which is the common ratio, is T2 over T1 which is minus 9 over 3, which is minus 3. Positive, negative is negative. B, we are expected to find our seventh term. So the Tn equals to AR to the power n minus 1. Our n term, you are expected to always take the n term, AR raised to the power n minus 1. And then when you apply the variables, A is 3, common ratio as we have determined is minus 3, and our nth term is 7. So T7 will be equals to 3 open bracket minus 3 raised to the power 7 minus 1. T7 will be equals to 3 open bracket minus 3, 7 minus 1, you will get 6. So when you simplify, when you raise any number to an even power, the result will be positive, irrespective whether the sign is positive or negative. In this case, minus 3 raised to the power 6, the result will give us 729. So by opening our bracket, the seventh sum, which is T7, will be equals to 3 times 729. 3 times 729. So our seventh sum multiplying 3 times 729, the result will be 2,187. 2,187. Then the C part of question 2, we are expected to find the nth term. We are to find the nth term. The nth term, which is given by Tn, equals AR raised to the power n minus 1. Tn equals AR raised to the power n minus 1. Now our first term, which is A, that is 3, and our common ratio we have determined is minus 3, while the nth term we don't know. We now have n as unknown, so Tn is equals 3 open bracket minus 3 into n minus 1 minus 3 raised to the power n minus 1. So the nth term for that GP is equals to Tn equals 3 open bracket minus 3 raised to the power n minus 1 minus 3 raised to the power n minus 1. My fellow students, you take note that minus 3 and 3, they are different terms entirely. So we cannot apply the laws of indices by picking one of the threes, because 3 and negative 3 are different bases. So you should not be tempted to apply the laws of indices in this case, because 3 and minus 3 are two different terms and the bases are not the same. So finally our n term for that GP is Tn equals 3 open bracket minus 3 raised to the power n minus 1. My fellow students, to summarize our lesson for the purpose of proper comprehension, you have to recall that from our definition, a geometric progression is defined as any sequence that the consecutive terms are having a constant multiple, properly known as the common ratio. And our geometric progression is equally known as the exponential sequence. So when we say exponential sequence, you should not misinterpret it with geometric sequence, because they are the same. They can be used interchangeably. So that is the definition of our sequence, geometric sequence. Now you should equally recall the nth term. You should equally recall that the nth term we should also recall that the nth term of a geometric progression is given by Tn equals AR raised to the power n minus 1. I repeat, nth term Tn equals to AR raised to the power n minus 1. You should try as much as possible to know this formula. Or the nth term is equally known as Un equals to AR raised to the power n minus 1. You should know the variables where our Tn is the n term, our A the first term, our R the common ratio. In fact, the good story about this is that the formulas are inculcated in the statistical 4-figure table, the YX statistical 4-figure table. But the advantage is that you need to know how to quote the formula. You should be able to apply the formula appropriately, derive your quantities, derive the variable given, and then try to identify the unknown. From there, you can be able to ascertain any question or solve any problem that is given to you. Just like the question 1 in examples. In our example, you remember question 1, we were given 32, 16, 8, while the question demanded for us to find the common ratio, we are equally expected to find the 7th term, we are expected to find the nth term. So taking number 1, you remember that the first term in our solution, the first term is 32 and the second term is 16. So R, which is a common ratio, will be T2 divided by T1. It will be T2 divided by T1, and our T2 is 16. Our T1 is 32. 16 divided by 32, the result will be 1 over 2. 16 divided by 32, the result will be 1 over 2. And in the B part, we're expected to find the 7th term. And bring out the terms given. The first term is 32. Our common ratio is 1 over 2. And our n term is 7. We're expected to deduce the n term, which is the 7th term. So in our application of formula, Tn is AR raised to the power n minus 1. Substituting the variable, we have Tn, which is T7, is equals to 32 multiplying 1 over 3 in bracket raised to the power 7 minus 1. 32 open bracket 1 over 2 raised to the power 7 minus 1. And 7 minus 1, you will get 6. So our result will move ahead to 32 multiplying 1 over 64. Where do we get 64? 2 raised to the power 6 is 2 multiplying 2 in 6 places. And if you do that multiplication properly, the result is 64. And 1 equally raised to the power 6 is 1 multiplying 1 in 6 places. Is still giving us 1. So finally, our result will be 32 multiplying 1 over 64, which is 32 over 64. And 32 divided by 64 will be 1 over 2. 32 divided by 64 will be 1 over 2. And then in example 2, we are equally given the sequence as we are expected to find the common ratio, the 7th term, and equally the nth term. Our common ratio is T2 divided by T1 or T3 divided by T2. So our T2 is minus 9 while our T1 is 3. That gives us the common ratio as minus 3 because negative positive is negative. Now our 7th term, from the nth term, Tn equals to AR raised to the power n minus 1. Substituting our values, our A is 3, our common ratio R is minus 3, while the n term, which is 7th term, we have T7 equals 3 open bracket minus 3 raised to the power 7 minus 1. And that gives us 3 open bracket minus 3 raised to the power 6. If we move ahead, our T7 will give us 3 multiplying minus 3 raised to the power 6 is 3 minus 3 times itself up to 6 places, and the negative sign will disappear because the power is even. The power is even. That is why it is 729. So 3 multiplying 729, the result will give us 2,187. 2,187. Therefore, our T7 is equals 2,187. And finally, the nth term, which is question C, we are expected to find the nth term of the geometric progression. So in this case, n remain constant because we are looking for the n term, which is the formula used in obtaining all the terms of the sequence. So our Tn equals AR raised to power n minus 1. Tn equals to AR raised to power n minus 1. Now substituting our variables, our first term is 3, our common ratio is minus 3, and then we have our Tn as 3 open bracket minus 3 raised to power n minus 1. Again, Tn equals to 3 open bracket minus 3 close bracket raised to power n minus 1. And I want my fellow student to realize that n term is to be taken note of. If the bases are the same, you apply the laws of indices. 3 and minus 3 are not the same, so you should not apply the laws of indices in that instance. Because of time factor, we will now pause for a while, and then before I move, my fellow student, I must give you an assignment, and you must take time to revise this assignment, because in mathematics, you must do it. Practice make perfect. So we have assignment for you. Question 1, we have find the common ratio in each of the following GPs. Find the common ratio in each of the following GPs. A, 128, 64, 32. Again, A, 128, 64, 32, dash, dash, dash. B, 10, minus 20, 40, dash, dash, dash. B again, 10, minus 20, 40, dash, dash, dash. Assignment 2. Number 2, we have given the GP 4, minus 12, 36, dash, dash, dash. We are expected to find the A, common ratio, B, the 7th term, C, the n term of the GP. Question 2 again, given the GP 4, minus 12, 36, dash, dash, dash. We are expected to find the common ratio as A, B, find the 7th term, and then C, find the n term. Thank you, my student. We have our reference section, our reference material you need to contact. Number 1, we have the New General Mathematics for SS3. New General Mathematics for SS3. The second reference, question and answers, Q&A, WAEC. Question and answers, Q&A, WAEC. And the third reference material, you have the Comprehensive Mathematics for Senior Secondary School. Comprehensive Mathematics for Senior Secondary School. I remain Mr. Monday Bakwai, and you can always contact me through my phone number 080-2525-9755. 080-2525-9755. That is my phone number. You can always contact me. So, thank you for listening. Stay home, stay safe, and God bless you.